So in 242, Unit 2, we do the urinary and respiratory system. So Lab 1 is designed to go over the anatomy associated with the urinary system. So we're going to start with an overview and then build some detail into that overview as we go along. So the organs within the urinary system are pretty simple. We have kidneys, and we have kidneys on either side, a right and left kidney. Sitting on top of the kidney, we have the adrenal gland, right and left adrenal gland, which are part of the endocrine system. The kidneys are designed to make urine, and the structural unit of a kidney is a nephron. So we'll look at the detail in the nephron a little later. So our nephrons make urine, and then the urine is drained from the kidney. So the tube that drains the urine from the kidney is called the renal pelvis, which leads into this tube, which is a ureter. So if I turn this model around, what you'll notice is the renal pelvis is posterior. The renal arteries and veins are anterior in the way in which the kidney sits in the body. So what that does is allows us to look at a kidney that's not attached in this manner and still recognize whether it's left or right by understanding that the renal artery and vein are anterior and the renal pelvis would be posterior. And then the ureter drains into an organ that's in the pelvic cavity, which is the bladder. And then the bladder is drained by a tube that goes outside the body, which would be the urethra. So we have the adrenal gland, the kidney, the ureter, the urinary bladder, and then what we can't see on this model, which we'll look at in a little bit, is the urethra. So if we take this model and then put it back into the body, then we can look at this model, and we can see that the kidneys set against the posterior wall of the abdomen. They're actually covered by parietal peritoneum, so the kidneys are described as being retroperitoneal, or behind the peritoneum. It's been removed in this model, and you can see that the renal artery and vein are anterior, and where they've been cut here, we can see the renal pelvis leading to the ureter. And then the ureter drops down into the pelvic region, which is where the bladder would be located. Okay, stop. All right, so if we look at a pelvis, then this green tube coming down is the ureter that would be dropping to the bladder. So in a woman, the bladder is this structure here. What sits superior to the bladder is actually the uterus. So we're seeing the uterus here. So this is the urinary bladder. And so the tube that drains the urinary bladder is the urethra. Now in women, the urethra drains in the vestibule, which is an opening between the labia here. And the urethra is very, very short. And so that's why women have a higher percentage of UTIs than men, is because the urethra is very, very short and it drains to a vestibule area, which is a moist environment. If we contrast that to men, then again, the ureter is what's passing down to what is the bladder here in a man. And then the bladder itself then is underlied by a gland that's part of the urinary system, which is the prostate gland. And then from there, the bladder passes through a muscular mass that we call the urogenital diaphragm. And then the urethra enters the penis. So the urethra passes through the prostate, through this urogenital diaphragm, and then through the penis. And then we void urine to the outside on a dry surface on the end of the gland's penis. And so because the urethra in men is quite large and it passes through several structures, then we subdivide the urethra in men. So the urethra passing through the prostate is called the prostatic urethra. this short piece of the urethra right here passing through this muscular mass, which is generically called the urogenital diaphragm, then enters this structure, which is the bulb of the penis. And when it enters the bulb of the penis, then the urethra is called the penile urethra or the spongy urethra. And it's called the spongy urethra because this is erectile tissue that we're seeing here that's surrounding the penis. So it's a porous tissue where blood pools to help create an erection in men. And so it's called the spongy urethra for that. And then the urethra exits here. So after we know that, if we look at this model and we look posterior on this model, then there's this walnut-shaped structure that's on the base of the bladder, and this is actually the prostate gland again. So we know that this model is actually a male because of the prostate gland, but they just didn't put the urethra and the rest of the stuff on there. So to control voiding urine, we have to have sphincters that allow us to close the urethra off. So as the urethra passes through the wall of the bladder, we have an internal urethral sphincter. It is involuntary smooth muscle, so that this is automatically controlled, part of the autonomic nervous system. If you'll recall from 241, we talked about the parasympathetic nervous system being SLUD, S-L-U-D-D, and the U was urinary. So the parasympathetic system causes this sphincter to relax, the sympathetic causes it to constrict. So as we pass down through the prostatic urethra, through the urogenital diaphragm, then we have an external urethral sphincter that's associated with this urogenital diaphragm. The reason is because to do an ejaculation, we want to make sure the semen passes out through the penis and not gets pushed back up into the bladder. So we have to have our internal urethral sphincter up here and our external urethral sphincter here with rhythmically contracts to create an ejaculatory event. So if we look at women, then in women the internal urethral sphincter is still in the bladder wall. The urogenital diaphragm is right here. So the internal urethral sphincter and external urethral sphincter are very, very close to each other. And there's no prostate gland in between them as we see over here. So if we look at a different model that allows us to see this area from a different view, then in a woman, if you look at the perineum and the external genitalia, then we have the labia majora we're seeing here and the labia minora internally. And what we'll see is that there's a muscle that runs in the labia that would surround the urethral opening. And so this muscle is called the bobospongiosus muscle. And that's the muscle we use to stop urine mid-flow. And so it's the one that constricts the urethra and helps form the external urethral sphincter. In men, it's associated with this structure, which is the bulb of the penis. So if we're looking at a man here, and we're posterior to the scrotum here, then this is the bulb of the penis. And notice that there's a muscle wrapping around the bulb of the penis here. And this muscle then compresses the urethra to stop urine mid-flow. And it's the one you use to express the last drops of urine. So this is the bobospongiosus muscle in men. The kidney is our major organ for making urine. And then we have the duct system that we were just referring to that drains urine out of the body. So the one thing that we have with the kidney is, and many other organs, the adrenal gland that sits on top of it would match, is that if the superficial tissue looks different than internal tissue, then we divide the organ into the cortex, which would be this outside layer of tissue here, and then this inside stuff going here, which is we call the medulla. So we're going to see a couple of organs this quarter that we can divide into cortex and medulla because they're structurally put together differently in the two layers. So because the kidney sits retroperitoneal, so it's behind the parietal peritoneum, and we talked about that earlier, then the kidney is not covered with visceral peritoneum. So the outside surface layer of the kidney is referred to as a capsule. So this is the renal capsule. And then inside the renal capsule we have this light stuff with this high amount of blood vessels in it, which we would say is the renal cortex. And then we have a layer here that's made of these dark patches repeatedly, which we would say is the renal medulla. And then we have a duct system that helps drain each of these parts of the medulla. So when we're looking at the medulla, we can divide the medulla into these triangular shaped masses that we call renal pyramids, and the tissue between these masses that we call renal columns, so that it's pyramid, column, pyramid, column, pyramid, column. So while we refer to this layer as the renal medulla, the pyramids are strikingly different than the cortex, and the columns are very similar to the cortex. So the columns are kind of cortical material passing down through this area where the medulla exists. Now each renal pyramid is going to drain urine into a little funnel that we call a calyx. And we have a small calyx and a large calyx. So each pyramid drains urine into a small funnel called a calyx. So this is a minor calyx, this is a minor calyx, this is a minor calyx still attached to this pyramid. This is actually a minor calyx where the pyramid was coming out here. So you can see it's actually a little funnel-shaped thing. And the part of the pyramid that fits down into this is called the papilla. So this is the renal papilla, which is part of the pyramid that fits into this. Now, if we look up here, we can see we have a minor calyx here, we have a minor calyx here, we have a minor calyx here, and they're all coming together into this area right here that we can see behind this one, and then we can see it down here. So that represents a major calyx. So this is a minor calyx coming together, and then this opening then represents a major calyx. And then the major calyxes come together to form this big opening, which is the renal pelvis. And then the renal pelvis actually then tapers and becomes the ureter that drains the urine. Because these calyces are like little funnels and they're round, you can't stick them all together and get no space. So as you can see in this model, this minor calyx has this little space in it. So this space is called a sinus. And so since it's part of the kidney, we say it's the renal sinus. And the yellow that's on the model here is adipose tissue. It's one of my favorite things. If you have an empty space, what kind of tissue are you going to put in it? The answer is always adipose tissue. So we put adipose tissue in these areas where there's an opening called the renal sinus.